Hello guys, good afternoon to everyone. My name is Mohammad Sabir and today I am here with you. And in today's sessions, we are going to discuss about a deflection problem. Basically, you can see the problem on the screen. Basically, it's a problem based on uniaxial loading. Uh, the first, we will try to understand what is the system. Okay, try to understand the configurations. Okay, and here we know it is a rigid bar. Basically, it's a rigid bar. Okay, is a basically a rigid bar. Okay, and the rigid bar is suspended by two wires. Two, you can say these two wires are the elastic. Okay, and the whole system is hinged by a roller support. Okay, now our purpose is to find out we have this system. What is the tension? Uh, how much tension is there in these two wires, and deflections of the point 2 and point 1. Okay, and what will be the reactions forces will be provided by the roller support to the rigid rod. This is the main purpose to solve this problem. This is a gate PIQ problem. Okay, the first we make a FBD of this rigid bar. Okay, we make a FBD of the rigid bar. When we remove the elastic wire, when we remove the elastic wire from while drawing a PD, the tension due to the wire 2 is T2 and tension due to the wire 1 is the T1, and the reactions is provided by the roller to the system is RA, and here is the point load which is applied on a midpoint of the rod. This is a P. This is a simple ability of this system. Okay, and now you know the basic understanding behind it. When you solve the problem which is based on the problem which on the strength of materials, like, okay, what things you should keep in your mind, because when you see a particular system which is based on dynamic kinematic analysis, how you solve, like how you approach the problem. The first thing you do the kind force analysis and deflection analysis, and then try to write a geometrical compatibility equations. Okay, in this case, what is the, because you know the system is indeterminate. The system is this is an indeterminate system because you know T2 T1 RA. Here we only can write it two equilibrium equations, but we we always we we also try to find out that these three variables, but we have only two equations. So how we can find the third variable by using a, how we can find a third variables? To find a third variable, we come we basically we come the concept of a we come with the concept of a geometrical compatibility concept. Okay, how we can write the equation for this particular system. When we apply the point load on the rigid bar, basically the system a system deflect, the road deflect as, like, okay, as the rod deflects as that. Okay, this is the basically a deflection is the point, the deflection of point one is the delta L1 is the delta L2, and now we will try to write the value of delta L1 delta L2. Okay, because this delta L1 and delta L2 we can find by using a stress definition of stress. Okay, definition of stress. When we basically write the equation of stress equations, we stress is basically is what stress is provided by your internal resistance force. In this case, internal resistance forces are tension forces. So we write a delta, and delta L1 is equal to T1 L upon AE, and delta L2 is equal to T2 L upon AE. Okay, and you can write the geometric compatibility equations, this is a similar use the similar triangle property and write these equations. Write this equation, this is equal to delta L1 upon A1 is equal to delta L2 upon B. When you put the value of delta L1 delta L2 in the equation 1, you can get this relation T2 is equal to B upon A T1. Okay, this is a simple. And now come to the, this is a moment equations. When we take a moment about a hinge point, you can visualize, you can see that T2 is equal to T2B plus T1A minus P1L is equal to 0. If you can look, you can see that the moment of T2 about hinge point is what? Is the T2B and is T1A, because why the negative signs come? Because the moment directions, the moment direction changes corresponding to this original internal stresses. Okay, so you can write that T2B plus T1A minus PL1 is equal to 0, because we are doing the static analysis, so we assume that the moment and force is should be 0. Okay, and behalf of that you can find B by A T1 B plus T1 A is equal to PL. By using this equation you can find the T1 and T2. Okay, you can find T1 T2, and it is so simple, but thing is that you can also find the RA, because when you write equilibrium equations, when you write equilibrium equation T2 plus T1 and plus RA is equal to P. By using this equation you can also find the RA reaction forces. Okay, because T2 T1, by using this equation you can find the RA. Now comes to the why the why we are why we are interested to find the tension on a on in this wires, because when you do the analysis, we try to find out the dimension of that particular elements. Okay, you know these wires can also be the elastic rod. Okay, so our interest is find the dimension of that particular elastic rod. Okay, like which material we should use so that it can sustain this much of load, this much of configurations. This is the main intention behind to solve the system, to do the force analysis. This part comes under the force analysis. Okay, this is not a new thing, it's a basic common understanding is that the basic approach to solve these type of problem is what? When you see the problem, the first write a moment equations, force balance, and then try to write a geometrical compatibility equations. Okay, this is a simple process to find a indeterminate type of problem, because it's an indeterminate type of problem. Okay, thank you, all the best.